Okay, so part B says to find all the values on the interval from -5 to 5 at which G has a critical point, and classify each critical point at the location as a local minimum, local maximum, or neither, and then we need to justify our answer. So here I'm looking at this graph. Remember, critical points are going to happen when the derivative of the function is equal to 0. So I'm going to write that, right? We need to know when the derivative of the function, so when g prime of x is equal to 0, which really means when f of x is equal to 0 is what we're looking for, right? That's how we know when something is a critical point. Right? We have critical points when this is happening. Okay, so the graph is 0 here, and the graph is 0 here. So we have critical points at those two spots. So we have a critical point at x equals -2, and we have a critical point at x equals 1. Now this point at x equals 2. At x equals -2, notice that it doesn't go from increasing to decreasing. It doesn't go from decreasing to increasing, right? It doesn't cross over and become from positive to negative on the graph, which means that the original graph was going from decreasing to increasing or increasing to decreasing. So this critical point is going to have neither, because the sign doesn't change. But 1, right? 1 in the graph, it's going from being negative to being positive, right? So 1 is going to be a local minimum because g prime of x goes from being negative to being positive. Which means, right, that the original graph went from decreasing to increasing. So that's why it would be a local minimum. So there I have justified my answer. I've classified the point, and that would be all you would need for that problem.